It's a big surprise. Nobody thought the ocean was this deep. So all of a sudden we've got scientists saying, why is that?
Space is empty, but the ocean is full of energy we do not understand. A recent deep-sea probe near the Puerto Rico Trench recorded a thermal spike that should not exist.
Is it a little hole? Is it a big hole? What kind of feature is it down there? There's a whole lot of questions you get when you find this one spectacular reading.
In a fraction of a second, the temperature jumped from near freezing to boiling. This was not a volcanic vent. It was a localized burst of heat that moved. This data point was quickly buried in technical archives, but it tells a terrifying story. Something down there is generating power. The ocean floor is not a graveyard. It is a hunting ground, and we are only just realizing that our presence there has been noticed by something capable of manipulating immense energy. Listening to the abyss scream. Basically, sound travels 5 times faster in water than in air. This means the ocean is an incredibly efficient conductor of noise. When the National Oceanic and Atmospheric Administration, or NOAA, first deployed its deep-sea listening array, it expected to hear the backdrop of the planet: earthquakes, icebergs cracking, maybe the distant engines of a supertanker. Instead, they recorded a sound profile that looked artificial. The frequencies were consistent, rhythmic, and originated from the Hadal Zone, the very deepest trenches where life is supposed to be sparse and silent. And get this. The most famous of these sounds, nicknamed the bloop, was recorded years ago and eventually attributed to an icequake. However, new recordings from the Mariana Trench show acoustic signatures that are far more complex. These sounds, sometimes referred to as the metallic train, sound like heavy machinery dragging across the seabed. They last for minutes at a time. If this were a geological event, the sound would be a sudden crack and a rumble, fading out as the energy dissipated. A continuous, rhythmic dragging sound implies a sustained source of energy. It implies agency. The sheer volume of these sounds is the real issue. To generate a sound loud enough to be heard across the entire Pacific Ocean, as some of these anomalies are, the source needs to be massive. We are talking about energy output greater than a nuclear submarine's active sonar ping. If a biological entity is making these sounds, it would have to be larger than a blue whale, significantly larger. But here's the catch. The biology of the deep ocean suggests that animals should not have air-filled cavities like swim bladders, which are usually used to make sound. At 11,000 meters, an air pocket would be crushed instantly. So, whatever is making these noises is doing it through a method we do not understand, possibly by grinding massive stridulating organs or vibrating fluid-filled sacs under immense tension. Scientists have tried to filter these noises out of the public data releases, labeling them as sensor interference or ambient tectonic noise. But the raw data tells a different story. The intervals between the sounds are too regular. Nature rarely works in perfect 4-minute loops. The horrifying implication is that the abyss is not empty. It is noisy, it is active, and the things making the noise are big enough to shake the water column for miles. The pressure at this depth is over 8 tons per square inch. To survive that, you need to be made of water, or you need to be made of something harder than bone. The idea that a creature, or a machine, is moving around down there, generating noise that rivals a jet engine, completely destabilizes our understanding of the ocean's capability to hide things. Everyone's obsessed with the idea of finding a megalodon, but the acoustic data points to something far stranger. A shark doesn't make a metallic grinding sound. The recording suggests something armored, something heavy, and something that does not care about being heard. The terrifying reality is that we are lowering our microphones into a dark room and hearing heavy breathing, but we are too afraid to turn on the lights. The noise is loud, but the silence that follows is what scares the experts. Biology versus the crush depth. When you look at the biology of the deep ocean, the math simply does not add up. Life is built on proteins. These are complex, folded molecules that perform every function in a living body. Under the crushing pressure of 11,000 meters, proteins should not be able to hold their shape. They should unravel, causing the animal to dissolve on a cellular level. It is like trying to build a house of cards inside a hydraulic press. Yet, we find the snailfish. This ghost-like, translucent creature holds the record for the deepest living fish ever discovered, found swimming casually at over 8,000 meters. It looks fragile, almost like a tadpole made of tissue paper. But its existence is a scientific miracle. So, here's the deal. To survive, these creatures are packed with a chemical called trimethylamine N-oxide, or TMAO. This molecule acts like a structural brace for their proteins, stopping the water pressure from crushing them. The deeper a fish lives, the more TMAO it needs. It creates a distinct, fishy smell, which is actually the smell of this chemical. But there is a hard limit. Calculations show that at around 8,200 meters, the concentration of TMAO needed to counteract the pressure becomes toxic. The fish would become so salty that osmosis would reverse, and water would rush into its cells, causing them to burst. According to every model we have, fish cannot exist deeper than this line. It is a biological wall. But here's the catch. We have seen shadows below that line. During a descent into the Serena Deep, a camera caught a glimpse of a creature that was definitely swimming, definitely large, and definitely well below the theoretical limit for bony fish. This suggests that life down there has evolved a completely different biochemistry, something that does not rely on TMAO, and that's putting it lightly. We are talking about a completely alien biology right here on Earth. If they aren't using the standard protein stabilizers, what are they using? Some researchers speculate silicon-based structures or high-density lipids that act more like solid plastics than biological tissues. Then there is the phenomenon of deep-sea gigantism. In the cold, high-pressure environment, invertebrates tend to grow to nightmare proportions. We have found amphipods, basically sea fleas, that are over a foot long. Imagine a flea the size of a cat. These creatures swarm in the darkness, stripping carcasses to the bone in hours. The crazy part is that we have only seen the scavengers. In every ecosystem, for every scavenger, there is a predator. The existence of foot-long armored shrimp implies the existence of something large enough to hunt them. You don't get massive herds of buffalo without wolves. In the Hadal Zone, the buffalo are giant worms and shrimp. The wolves? We haven't caught them yet, but we know they must be enormous to withstand the cold and hunt such armored prey. The scariest part of this biological puzzle isn't the fish we see. It's the energy required to sustain them. There is very little food down there. Marine snow, dead plankton and poop drifts down from above, but it's not enough to support a large population of giants. This implies there is another food source we are missing. Could there be a predatory species that hibernates for decades, waking up only when a whale falls occurs? Or perhaps one that feeds on the chemical energy of the Earth itself in ways we haven't discovered? The silence from the scientific community regarding the food chain gap is telling. They know the numbers don't balance. There is too much life and not enough food, which means something is eating something else that we haven't found yet. The biology is impossible, but the ground they swim over is even more unstable. The Daikoku sulfur pits. While the water is freezing, the floor is burning. The popular image of the trench bottom is a cold, muddy wasteland. But in reality, the Hadal Zone is geologically violent. We are looking at the seams of the planet, where the crust is being recycled into the mantle. This process releases massive amounts of energy. Specifically, look at the Daikoku Seamount. Located near the Mariana Arc, this underwater volcano features a pool of molten sulfur. This isn't just hot water. It is a bubbling lake of liquid sulfur, glowing with a sinister violet hue, sitting under thousands of feet of ocean. It's not that simple, though. You might think the water would just boil and cool the sulfur down. But the pressure is so intense that it acts like a lid on a pressure cooker. The water can reach temperatures of 700 degrees Fahrenheit without boiling into steam. This superheated fluid shoots out of hydrothermal vents, carrying dissolved minerals that build massive chimneys instantly upon contact with the cold sea. The horrifying part is the unpredictability. The sensors placed near these vents frequently record thermal excursions, sudden, massive spikes in temperature that cover a wide area. It is as if the ocean floor momentarily opens up. If a submersible were caught in one of these invisible plumes, it wouldn't just be crushed. it would be boiled alive instantly. What most people don't realize is that these vents are often surrounded by colonies of tube worms and blind crabs. They thrive on the toxic chemicals. But the geological records show something disturbing. Entire colonies are frequently wiped out overnight. One day they are there, the next day the area is barren, scoured clean by a violent release of energy or a massive slump of the sediment. Then there is the gravitational anomaly. In the Puerto Rico Trench, the gravity is actually lower than in the surrounding area because the trench is so deep and the crust is so thin. But underneath that, there are pockets of ultra-dense material that pull on the sensors. NASA has mapped these anomalies, and they look like bruises on the face of the planet. These density spikes suggest that massive chunks of the mantle are breaking off and sinking, a process that could trigger tsunamis with zero warning. The floor of the trench is not stable ground. It is a chaotic conveyor belt of destruction. And get this, we have found evidence of megaturbidites, massive underwater landslides that move cubic miles of mud in seconds. These aren't just dirt falling down a hill. They are avalanches of liquid earth that travel at highway speeds, burying everything in their path. The cables we lay across the ocean floor for the internet are frequently snapped by these events. When scientists see the data from these underwater landslides, they stay silent because there is nothing we can do to stop them. They are reminders that the solid earth is fluid on these timescales. The horrifying truth is that the bottom of the ocean is a bubbling cauldron of toxic chemicals, liquid rock, and shifting mud, all hidden by the dark. The juxtaposition of the freezing water and the hellish heat creates a dynamic, explosive environment. It is the most hostile place on Earth, yet we keep trying to send fragile machines down there, and sometimes the planet pushes back. The ground is trying to kill us, but something else is leaving a mark. The scars on the lander. This is where the story shifts from passive observation to active contact. We can explain away sounds with ice, and we can explain away heat with volcanoes. But we cannot explain away torn metal. Deep-sea landers are built like tanks. They use grade 5 titanium alloy and syntactic foam to resist the crushing weight of the water. When they come back up, they should be covered in mud, maybe a little biological slime. But recently, landers dropped into the Kermadec, and Mariana trenches have returned with deep, parallel gouges in their sides. Titanium is one of the hardest metals we use. To scratch it requires immense force and a material that is even harder. Mud cannot scratch titanium. Snailfish cannot scratch titanium. So, here's the deal. Something down there is hard enough and strong enough to damage our toughest equipment. The marks often look like scrapes, suggesting a glancing blow from something massive. If it were a rock, the dent would be jagged and irregular. These marks are often smooth, continuous lines. It implies a deliberate interaction, a curiosity. Something bumped the lander to see what it was, and that bump was powerful enough to compromise the hull. Then there is the mystery of the missing bait cages. Researchers will attach a steel cage filled with mackerel to the lander to attract amphipods. On more than one occasion, the lander has returned with the attachment arm bent or snapped and the cage completely gone. Basically, a steel cable does not just snap on its own. It takes thousands of pounds of tension. And there are no currents at that depth strong enough to rip steel. The only logical conclusion is that something grabbed the cage and pulled it until the cable failed. What eats a steel cage? Or rather, what is strong enough to rip it off to get to the fish inside? The most chilling physical evidence, however, are the tracks. High-resolution sonar scans of the trench floor have revealed long, winding trenches in the mud. These aren't the small burrows of worms. These are furrows 3 feet wide and miles long. They look like someone dragged a heavy pipe across the bottom of the world. Some scientists argue these are caused by geological slumping, but slumps go downhill. These tracks meander. They turn. They loop back. They show behavior. A geological event does not change its mind and turn left, and that's putting it lightly. If these are tracks from a living creature, it would have to be a bottom feeder of colossal size, likely a soft-bodied organism that doesn't show up well on sonar, dragging itself through the nutrient-rich ooze. The idea of a 100-foot worm or a massive flat scavenger scouring the trench floor is consistent with the track data, even if it sounds like science fiction. The refusal of major oceanographic institutes to comment on the non-geological striations is the biggest red flag. They have the data. They have the 3D maps. They see the trails. But admitting that something is leaving tank tracks in the mud at 36,000 feet requires rewriting the textbooks. They prefer the safety of silence over the chaos of a new discovery. The tracks are scary, but the reason for the silence is the true horror. What they are hiding. It is a cliché question, worn smooth by decades of cocktail parties and introductory oceanography lectures. Why do we know more about the cratered, rusty surface of Mars than the bottom of our own ocean? The standard answer is logistical. It is an answer about physics and engineering. We tell the public that space is a vacuum, which is difficult, but water is a weight, which is crushing. We explain that radio waves travel easily through the emptiness between worlds, but die almost instantly in salt water. We speak of the difficulty of building hulls that can withstand 8 tons of pressure per square inch. These are all true statements. They are the comfortable, sterile facts that allow us to sleep at night. But they are not the whole truth. The reason we have mapped less than 20% of the ocean floor is not just because it is hard to get there. It is because the data we are getting back is frighteningly inconsistent with our understanding of the world, and we do not know what to do with it. There is a pervasive myth that science is a cold, objective machine, hungry for new discoveries. The public believes that if a researcher found evidence of something extraordinary, a biological impossibility, a geological contradiction, they would rush to the presses, eager for their Nobel Prize. But the reality of academia is far more conservative and driven by a primal fear, the fear of being wrong, the fear of the outlier. Scientists are not silent because of a grand, cinematic government cover-up involving men in black suits and non-disclosure agreements. They are silent because of the terrifying mundanity of peer review. In the scientific community, you do not publish a paper saying, "Something massive and unidentifiable scratched my robot." You publish data. You publish repeatable, verifiable models. And when the data makes no sense, when the biology implies metabolic rates that defy thermodynamics, when the acoustics possess a rhythm that suggests artificiality, and when the geology looks less like erosion and more like excavation, you do not publish. You file it away. You label it instrument error, or sensor drift, or simply anomaly. The horrifying truth is that our model of the Earth is incomplete, and the gaps are not merely empty spaces. They are inhabited. We have made the mistake of assuming the deep ocean is simply a darker, colder, higher pressure version of the surface. We treat it as a gradient, a sliding scale where things just get a little more extreme the deeper you go. This is a fundamental error in categorization. The deep ocean, specifically the Hadal Zone below 6,000 meters, is not just a different environment. It is a completely different world with different rules. It is an alien planet wrapped around the core of our own. The biology we see down there shouldn't exist. We find gigantism in places where there is no food to support it. We find creatures operating on metabolic timescales that suggest they have been alive since before the ice ages. But more disturbing than the biology is the physics of their interaction with us. What most people, even those in the field, fail to realize is the sheer violence of our presence. We characterize our exploration as observation. We frame it as a passive, benevolent curiosity. We float down in our submersibles and send our remotely operated vehicles on tethers, believing ourselves to be like birdwatchers in a forest. But we are not birdwatchers. We are intruders. Imagine a dark, silent ecosystem that has been undisturbed for 10 million years. The creatures here have evolved in a world of absolute stillness, sensing their environment through delicate pressure waves and faint chemical trails. Then, we arrive. We drop loud, bright titanium boxes into their sanctuary. Our thrusters scream with cavitation noise that, in the density of water, travels for miles like a shockwave. Our high-intensity halogen and LED arrays cut through the eternal night with a blinding violence that can permanently blind photosensitive organisms. We are not subtle explorers. We are dropping a rave into a cathedral. We are poking a sleeping bear in the pitch black, and we are genuinely surprised when it swats back. The events recorded at 11,034 meters, the bottom of the Challenger Deep and other trenches, are not random glitches. If you look at the raw logs, ignoring the sanitized reports released to the public, a pattern emerges. It is a pattern of defensive escalation. Consider the mechanical failures that plague deep-sea expeditions. A tether, reinforced with Kevlar and steel braid, rated for 10,000 pounds of tension, does not just snap. Physics dictates that it must be pulled, and pulled with a force that exceeds its breaking point. Yet year after year, ROVs go dark. We pull up the tethers and find the ends frayed, not by the clean slice of a jagged rock, but by tension and torsion. Something held the machine. Something pulled back. Then there are the scars. When we do manage to retrieve our equipment, the titanium frames often bear witness to impossible trauma. We find deep gouges in the syntactic foam buoyancy blocks, foam that is so dense you could hit it with a sledgehammer and leave no mark. We find scratches on the camera housings that look suspiciously like raking claws, or perhaps unintentional collisions with things much larger and harder than the sediment should allow. The ocean floor is the last true mystery left on Earth. The evidence suggests we are sharing this planet with giants we refuse to acknowledge. Do you think the scratches on the landers are from rocks, or is something hunting our robots? Let us know your thoughts in the comments, and don't forget to like and subscribe for more deep-sea truths. Thanks for watching.